Hello, I'm Ben Holken. I'm an Associate Professor in Mechanical and Mechatronic Engineering at UTS, and I'm here in the Vibration Lab to do the second of two videos on the mini shaker, the mini inertial shaker, which is this little device over here. I've shown what's in the box in a previous video. This is a Qsources small inertial shaker, and here's the force cup, which is what gets mounted to the structure. So there's a box of accessories over here, some extra force cups. We're just using those one at a time. We don't want to use them all at once. There's some metallic tape, some grease, some tools, and I've described the use of all of those in the previous video. At the start of this video, I'm going to apply the force cup to the sample. So we've got a small ring around here, a flat ring, circular ring, and we've put some metallic tape on the sample. So for non-metallic samples, we need to be able to encourage some heat to be drawn out of the transducer. If we drive this shaker quite hard, it will generate some heat. So the metallic tape is there essentially as a heat sink. I've got some super glue here, and we really just need a very small amount of super glue around the ring here. We don't need to fill up the hole with super glue. Super glue works by putting one very thin molecule of adhesive cyanoacrylate between the two surfaces, the two metallic surfaces. And this is obviously a flat surface, this is a cylindrical surface. So I'm going to mount this carefully, and we're going to essentially have like a point contact. If we just use a small amount of super glue, it should go off pretty quickly if we apply some pressure. And that should hopefully stay in place. Although maybe not quite. So maybe just try a little bit more glue. It's a bit fiddly, sometimes you just need a wee bit more, but like I say, not too much. If we do put too much glue on, we can get the glue off either using acetone as a solvent remover, or we can use, in this case, the mechanical scraper tool, which is provided also in the kit, which I showed in the previous video. So I'm just trying to mount this thing so that it's going to excite the structure in the radial direction, and because it's a small line, I'm actually going to provide it with some support also with a glue gun. So the glue gun's glue's just there to give it a bit of extra support in case we get any side loads, but it's not actually providing the connection between the shaker and the structure. So now I've got my two inputs, which I've shown these in the previous video. They can go to the amplifier output cable. Doesn't matter which way around we connect them. And I'll just let that perhaps go off slightly. And in the meantime, I'll get some grease. This is a small tub of grease. So we're just going to put a little bit of grease around the inside of the shaker here. And that's going to just prevent us having friction, causing a little bit of a loss of excitation force when we mount the shaker onto the force cup. Now there's an O-ring inside of here, so it's going to need to be pushed relatively firmly, and it should sit home, and it feels a little bit stiff at the moment. I think that should be a little bit freer. So that O-ring is, and I'm trying not to obviously pull the force cup off now as I check the connection there. I feel like it just needs to, maybe just pushed it a little bit too far on. So super glue is very good in compression and in tension, but not so good in shear. I'm going to see how we go there when we apply some kind of an excitation signal. So we'll do that from the acquisition system, which in this case is the PSV software. We have the amplifier here. We've connected a signal from the generator output on the acquisition system to the input on the amplifier, and we can use the acquisition system here to create some sort of a signal. Might be a sine wave, might be a periodic chirp, burst random, pseudo random, etc. We'll leave it with the periodic chirp, which was what we've used previously. We're sweeping between, or up to 10 kilohertz in this case, and Strangely, this button on the front of the box, so it's ready now because we've turned the power on at the back, but this red button, when it's in, is essentially not running, and when it's out, it's running. So we use a periodic chirp signal with an amplitude of 0.2 volts. Do not use very high amplitude input signals for this amplifier because we'll very easily damage the device. So 0.1, 0.2 volts is sufficient excitation. And then we can turn on the generator here, and then we can turn the power on for the amplifier. And if you come around to look at the structure, then you should be able to hear on the video that periodic chirp sweeping through those frequencies. So now our shaker is exciting the structure, and we have minimal mass loading because this mass here of the shaker is essentially floating. All the mass that's attached to the structure is the force cup. And now we can go ahead and do our modal analysis. Thank you.